Okay, so today we are going to go over the theory behind rate of reaction. What is it that causes reactions to speed up, slow down, or is it possible to maintain the rate? And we have already gone through how to measure the rate. We figured out that if we can measure any change with respect to time, we can measure the rate, and then we draw the table, and then we look at the graph, and the gradient of the graph tells us how the rate goes. Okay, so the theory behind this is collision theory. And collision theory gives a very simple explanation for why reactions happen, how reactions happen, not why, and how we can increase or decrease the rate. So the idea is that reactions happen because of successful collisions. So particles must collide successfully for a reaction to happen. That's the thing. They must collide successfully. Now, this successfully word is important. I mean, how do we know whether this reaction is successful or not? So for that, the idea is that successful collision is the one in which they collide with sufficient energy, which is greater or equal to activation energy. Okay, so their energy should be more than or equal to activation energy, and only then they will be able to collide. And second, that they must collide with correct orientation. Orientation can mean two things. One is the angle at which they collide, and second is the particles that collide. So the idea, I'll give you an example. Let's say I want hydrogen to react with chlorine and make 2HCl. Now, this reaction will have some activation energy. Now, if you remember activation energy, what was that? It is the minimum energy required for a reaction to start. And this is an exothermic reaction, which means its graph will be like this. It will start somewhere, it will go up, then it will release a lot of energy, and then it will become constant again. This part, where it is going up, this one, from the basic starting point to the top, this is activation energy. Hydrogen and chlorine should have enough energy to collide, otherwise they will not be able to do this. Okay. And I know this is exothermic because of this delta H, which is going down. So from start to end, this is the change in energy, and this is negative, this is going down. So on the reactant side, I have hydrogen and chlorine. On the product side, I have 2HCl. Now, all of this is happening in the same vessel. There's one container in which I have hydrogen, chlorine, HCl. Now, here's the thing. If hydrogen collides with chlorine, then reaction might occur. Only if they collide with energy that is greater than or equal to activation energy will the reaction definitely occur. Otherwise, it will not. So that's the first thing, that hydrogen and chlorine, if they keep colliding, but they don't have enough activation energy, then they will not react. But if they have energy which is equal to or greater than activation energy, then they will react and they will produce HCl. Okay, in the same container, I also have hydrogen, chlorine, and HCl. What if hydrogen molecule collides with another hydrogen molecule? Will the reaction occur? No, because that's not the reaction here. What if hydrogen collides with HCl? What if chlorine collides with another chlorine? What if chlorine collides with HCl? I mean, all sorts of collisions can happen. But only the right collision between hydrogen and chlorine will make the reaction happen. Any other collision will not. So the idea comes down to that we need successful collisions, and there's only a few successful collisions possible. Not all collisions are successful. And they must collide between the right particles at the right angles, not the right angle, I mean correct angle. So that is correct orientation. And they must collide with enough energy so they are able to do the reaction, continue with the reaction. If they collide but they don't have this, they will not be able to do. But there are ways to increase or decrease the rate of successful collision. So the collision theory says that rate of reaction is on the frequency of successful collision. So rate of reaction increases or depends on frequency of successful collision. Okay. Frequency means the idea of time, that they must collide with enough energy, with the correct orientation, a fixed number of times per unit time, or with the correct frequency for us to get the reaction going. So now the idea about time is even more important, and obviously that's part of it.